Assalamualaikum everyone. In today's video, we are going to discuss about racemization, and in this topic, we are going to discuss what is racemization, what are its physical properties, what is its significance, and we discuss some other examples of it. So, before we are going to start our lecture, I request you to please subscribe my channel, like my videos, and also press my bell icon to get notification of all the videos which I have uploaded. So let's start the lecture. So first, you have to discuss what is the racemization. So racemization is actually a process by which you are converting your optically active compounds into a racemic mixture, and this racemic mixture composed of equal amounts of D and L isomers. D and L isomers mean dextrorotatory and levorotatory compounds. In this racemization, you are using your heat or some kind of chemical reagent or light. By three these things, you are undergoing the process of racemization. So what is this racemization? Actually is a process of conversion of an optical active compound into a racemic mixture. Now what is a racemic mixture? Racemic mixture is a mixture which contain equal amounts, mean 50-50 amounts of dextrorotatory and levorotatory isomers. So racemic mixture is also a optical inactive compound. So the resulting product which is produced is called a racemate. Means your racemic mixture can also be called as your racemate. Okay. So now what I am doing, I am mixing. For example, if you contain in this beaker, you have a dextrorotatory solution. Okay, so now I have another beaker, and in this beaker I have levorotatory optical active compound. Now I am mixing both of them in a beaker, and now what results I have got? I have got an optical inactive compound, a mixture, and this mixture is called as recipic mixture, and it is optically inactive. And this whole process is called as racemization. So I hope you understand that what is the racemization. So what things are helping in the process of racemization? Three things actually. First is the heat, second is the chemical reagent, and third is the light. So in the presence of three these reagent, process of respiration is occurring. So here is mentioned that it is a conversion of optical active compound to the racemic mixture, and the racemic mixture contain 1 molar ratio of enantiomers, and this is called as racemic mixture. It contain equal amount of positive and negative forms. So you cannot write capital D and capital L enantiomers, because the always you have to write small d and smaller. So this is a mistake here, so you have to correct it. And racemization can be proceed through a number of different mechanisms. It has particular significance, and as the different enantiomers have different pharmaceutical effects. So now we discuss and move on to the next slide. So now we are going to discuss about the physical properties of our racemic mixture. So now let's start it. So in solid state, racemic mixture may have different physical properties, either of their pure enantiomer, because of different intermolecular interaction can occur between them. So they are saying that your racemic mixture can have different physical property. You cannot say that they have same physical property, because you know very well a racemic mixture is made from two different optical active compound which have different rotation in the specific light. So therefore they cannot have same physical property. Okay, the chain from the pure enantiomer into the racemate is the change of its density, its melting point, solubility, its heat, fusion, refractive index. All of these properties changes. If I give some example to you, for example, I give the example to you of the lactic acid. So if you see the lactic acid, the melting point, if you see the melting point property of this lactic acid, so I am donating lactic acid with the La. So now if you see the positive lactic acid melting point means D isomer of lactic acid, so its melting point is 26 degree. Okay, and if you see the melting point of negative lactic acid mean it's L isomer, so its melting point is 26. But if you see the racemic mixture of this lactic acid and the racemic mixture of lactic acid is represented by plus and negative sign both. So whenever a plus or negative sign both are written, it means that it is a racemic mixture, and the melting point of this racemic mixture is 18 degree. So now you can see here how the melting point is affected. Actually your melting point is 26, but when you form the racemic mixture, its melting point decreases. So whenever you are going to form racemic mixture, always two things happen. First is melting point always decreases. Whatever its original melting point, its melting point decreases. For example in lactic acid 26 से 18 तक decrease हुआ. Now the second thing is that its solubility increases, so it become more soluble than its first form. Okay, sorry for the bad writing, but you have to see it. Okay, so these two physical properties are changing due to this formation of racemization, due to formation of racemic mixture. I hope you will understand this concept. So another thing written here, that the crystallization recipient can separate the positive and negative forms out. So this is dealing with the how we can separate them. So however in liquid or gaseous form, a racemic mixture will behave with the physical properties are identical or near identical to the pure form. So they are trying to say that if we have a solid racemate, then it is very difficult that they have a same physical property, they have different physical properties. But if they are in the form of gaseous or a liquid form, then there is a possibility that they can have same physical and chemical properties. Okay, so now we are going to discuss the biological significance of this reaction. Okay, so most of the biochemical reactions are stereoselective and so only one stereoisomer will produce the intended product while the other simply do not participate in the side effects. So of note that L form of amino acids and D form of glucose, primary glucose, are biological reactive form, and they are using in a lot of things. Okay, whenever you see amino acid, and the most important thing you have to mention there, that in our bodies all the amino acids which are present are in the L form. So this is very important for us. So it means all the amino acids which are present in our body, whether it is glycine, alanine, leucine, lysine, cysteine, methionine, serine, threonine, whether it is whatever it is, all they have L forms in our body. Okay, this is the concept. And the D form of sugar means the D form of your glucose. So you know very well that D form of glucose is more abundant and is uh, uh, more abundant and more useful, कह सकते हैं. So more useful in our body, which is called as glucose. So 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 this is due to the effect many biological molecules are chiral, and the reaction between the specific enantiomer produce their stereoisomers. Notable the fact that all the amino acid residue exist in L form, but however bacteria produce D amino acid residue, and that polarize into the short peptides also found in the bacteria cell wall. So here they are explaining that in the bacteria the D amino acid has its importance because D amino acid is used in the polymerization of polypeptides. Okay, but in the humans L form is majorly used. Okay, now here is given that the stereoactive nature of most biochemical reaction, different enantiomer may have different properties affecting many physical drugs. Many जो drugs have psychotropic drugs showing different activities. For example ये एक drug का नाम इन्होंने दिया हुआ है. So dispense as the racemic salt while the more active reserve as a prefective. तो आप इस पैराग्राफ को छोड़ेंगे, ये जो नीचे वाला पैराग्राफ है this is really important. Okay, so यहाँ पर हमारे काम की ही बात लिखी गई है. तो रेसिमाइजेशन और फार्मास्यूटिकल ड्रग्स की रेसिमाइजेशन यहाँ डिस्कस की गई है. कर इन विट्रो For example, ये thiramidine, this is a pharmaceutical drug as the R enantiomer effective against the morning sickness को ये treat करता है, while the S enantiomer, R enantiomers mean and S enantiomers mean. What is mean by them? So R, the word mean, R means racemate, means they are a positive form, means a D isomer. So this is the D isomer, and S isomer is small s and negative form. So D isomer of a thiadomamine is used in against the morning sickness, to treat the morning sickness, and its L form is used to treat terragonic disease, causing the defect when we take for the first trimester of pregnancy. Okay, so नाउ यू सी अब वन ड्रग, ठीक है, वो एक ही ड्रग है, बस उसके डिफरेंट आइसोमरिज्म डिफरेंट डिजीजेस को ट्रीट कर रहे हैं. सो अब आपको पता लगा कि रेसिमाइजेशन की क्या इंपॉर्टेंस है. सो एक दफ़ा फिर मैं आपको इसकी रिवाइज करवा देती हूँ. थाइलाडोमाइड एक ड्रग है, थैलाडोमाइड. सो इसके दो आइसोमर्स हैं, एक है रेक्टस और एक है सेस्टर्स. सो आर एनेशियोमर भी कहते हैं हम इसको, एस एनेशियोमर भी कहते हैं. आर एनेशियोमर होता है पॉजिटिव और एस एनेशियोमर होता है नेगेटिव. सो आर एनेशियोमर यूज़ हो रहा है मॉर्निंग सिकनेस में, एंड एस एनेशियोमर इज यूज इन अ ट्रॉन्कजेनिक. इट इज़ टेकिंग इन द फर्स्ट ट्राइमेस्टर ऑफ प्रेगनेंसी. ओके, so now one of the enantiomer industry to immune, both forms can be later used in the blood. Serum drug is therefore not considered safe for use by the woman of childbearing, while has other uses. So it is tightly controlled. Dopamine used to treat the multiple anemia. So they are saying that this drug is not safe. It has some defects on it. So therefore this drug is not so common. But they have given such example for you, not importance of it. Now another drug is ibuprofen. So it is an anti-inflammatory drug, and it has some biological importance because it as enzyme is much more active than the R enantiomer. ओके, सो दे हैव गिवन दैट इब्रोफेन के अंदर जो उसका ऐसा आइसोमर है वो ज़्यादा रिएक्टिव है देन द आर आइसोमर के. सो एक और इन्होंने दिया हुआ है क्लेक्सोप्रोटीन, तो ये एंटी डिफ्रेजेंट है और ये भी एक्टिव है हमारे के लिए. और कॉन्फ़िगरेशन स्टेबिलिटी इस ड्रग की ये है कि फार्मास्यूटिकल रिसर्च में यूज़ होता है और बहुत जगह पे यूज़ होता है. इसके अलावा हम अगर फॉर्मेशन ऑफ रेसिमाइजेशन की बात करते हैं, सो फॉर्मेशन किस तरह से हो रही है इनकी रेसिमाइजेशन की, सिंपली ये अचीव हो रही है कि हमारे पास इंटर कन्वेजन हो रही है यहाँ पर, और प्रोटोनेशन के ज़रिए कुछ प्रोसेसेस हैं जो हो रहे हैं, जैसे सब्स्टिट्यूशन रिएक्शंस हैं उसके ज़रिए से हो रहा है, एलिमिनेशन रिएक्शंस है उसकी जगह ज़रिए से हो रहा है, सॉरी फॉर डैट. और इसके अलावा इलेक्ट्रोफिलिक सब्स्टिट्यूशन हो रही है, फ्री रेडिकल सब्स्टिट्यूशन रिएक्शन जो है वो हो रहे हैं. दिस इज़ रेसिमिक. लास्ट में हमें दिया हुआ कि डिस्कवरी कैसे हुई, तो लिविस पास्टर ने डिस्कवर किया था कि ऑप्टिकल एक्टिविटी किस तरह से होती है और कहाँ से होती है, और ऑप्टिकल एक्टिव कंपाउंड्स भी उन्होंने देखे थे, जैसे ग्रेप वाइन में, पैराटाइक एसिड में, इन जगहों पे उन्होंने ऑप्टिकल एक्टिविटी के कंपाउंड्स को देखा था. सो आई होप कि आप लोगों को आज का लेक्चर जो है वो समझ में आ गया होगा और इसका सारा कुछ आपको कोई भी कन्फ्यूजन इसमें नहीं रही होगी. और अगर आपको फिर भी कोई भी कन्फ्यूजन है तो आप मुझसे कमेंट करके पूछ सकते हैं, और मिलेंगे नेक्स्ट लेक्चर में. तब तक के लिए अल्लाह हाफ़िज़. अपना बहुत सा ख्याल रखिएगा, मेरे लिए दुआएं कीजिएगा. मिलेंगे नेक्स्ट लेक्चर में. अल्लाह हाफ़िज़.